Hey guys, Nate here. In this video, I want to show you how to automate your Python code to save you time on a common data science task. Specifically, we'll automate the import of CSV files to a Postgres database. The Python script will not only help you import a CSV file to a Postgres database, but it will actually clean up the file names, clean up the column headers, and just prepare the entire data set to be uploaded to the database itself. So this is actually a continuation of my last video where I showed you how to create a Python script that will upload a CSV file to a Postgres database. The continuation of the last video, or the next iteration of the last video, is basically just to automate the entire process so that you don't need to change a single line of code, and for it to also be able to handle multiple files so that you can just place multiple CSV files in a given folder and let the Python script just handle all of it automatically. So let's start coding, but before that, please hit the subscribe button if you like this type of content. All right, so I've just opened up the Python notebook from the last video. So everything is exactly the same. The only thing I've added was a few categories here, or titles, just to add some clarity and separate the code out a little bit so you guys know what's going on in each section of the notebook. So again, this Python notebook will import the CSV file into a pandas data frame, clean the table name and column headers, then write the SQL statement to create the table, and then insert the values to the Postgres database. The whole thing was done manually, meaning that I had to type out the table names and the column headers, and then also manually find the file. So what we want to do in this version is to essentially refactor the code so that we automate the entire process and that this notebook can also handle multiple CSV files. Okay, so the first thing we want to do is import our libraries. So the first step is to find CSV files in the directory. And so originally we used this ls command here, which is a bash command that essentially will find all of the files in your current working directory. So right now we actually have 4 files. And so let me just go to the project folder here. What you see is our Python notebook. So I just named it CSV import automation. And then we actually have 3 CSV files that we want to import into our database: customer contracts, customer demo, and customer engagement. So this ls command basically finds all of the files in the directory. We actually only want this command to find CSV files and not this IPYNB file, because we want to convert all of these CSV files into pandas data frames, as you see in the following code here. So we need an automatic way to essentially identify only CSV files in our folder. So this is going to be a multi-step approach here. So the first step will be to find CSV files in my current working directory. Next, isolate only the CSV files and ignore the other files in the directory. And then what I'm going to do is make a new directory and then move the CSV files in the new directory so that I can process the CSV files in isolation. All right, so let's start with the first step here. Find CSV files in my current working directory. So instead of using the ls command, what we want to do is utilize the OS library and use the list directory method here, which basically does the same thing as ls. What is needed in this method is to provide the current working directory path. We could also use the get cwd method to get the current working directory. So if I actually run this line of code here, I get the same thing I got when I ran ls, which was a list of files in this directory. The only difference is that this is saved in a list itself, while this is just an output of ls. So you see in this list right here, we have 3 CSV files that we want to isolate, and we want to actually remove this file right here, as well as this hidden file right here. So in order to do that, what I want to write is a for loop that will progress through the list and check whether or not each file in this list has a CSV extension. And if it does, keep it, and if it doesn't, throw it away. So the for loop is going to look like this. For file in, and then I'm going to use this. So this right here is essentially this list of 2, 3, 4, 5 files, and this file is basically the placeholder variable where it's going to progress through each one of these elements in the list. So for file in OS list directory, if file ends with .csv, let's save that CSV file in a new list, and let's call that new list CSV files and append that file name to CSV files. So I also need to create an empty list just to initialize this list right here. And so if I run this, I think it worked. And so what we can do is just test it out and see what we get. So CSV underscore files will give us a list of only CSV files. So this is exactly what we want. So what I can do now, just to clean up the code, is this actually isolates only the CSV files. Now I'm going to delete that, and we'll work on this third step here, which is to make a new directory. So to create a new directory, I think the easiest way is to write a bash command. So similar to this ls that we use to find all of the files in the directory, we can use something like make directory and then name of directory. So the name of the folder would basically be placed right here, and this mkdir is the command to make a directory. So we want to automate this process here. Okay, so the first thing what I'm going to do is create a variable called dataset directory, which is the name of the directory. It's the variable, and I'm going to call this directory datasets. And next what I want to do is create the bash command to make a new directory. So that bash command again is basically going to look like mkdir and then dataset directory, which is in this case datasets. And so in order to do that, I'm going to create a variable mkdir, make that equal to basically this string right here. So mkdir and then a placeholder value, and then in this placeholder value here, we're going to add dataset dir. All right, so basically what this is going to do is dataset dir contains this string right here. This string datasets is going to be put into this placeholder value here. So if I actually output what mkdir looks like, it should be exactly this, but instead of datasets dir, it's datasets, and that's exactly what we have right here. So the next thing to do is actually run that bash command. In order to run that bash command, we'll just use the OS library again, use system, and then pass through the variable mkdir, which is this. Okay, and so the next thing and the last thing I want to do is just add some error handling to it. So I'll say try this, and if I get an error, just pass on it. And one reason why we want to add the error handling to this whole process is because sometimes this folder already exists, and so you'll get an error message when you try to make a directory that already exists. So in order to just bypass that error, I just have this error handling try except code in there. So there are definitely downsides to this. One downside is you might not have sudo permissions to actually make the directory. And so if an error pops up, or if that sudo error pops up, then it's just not going to make the folder and you won't really know. So it's really up to you on whether or not you want to add this try except code here. So the last step is to move the CSV files in the new directory. So if I just create a new code block here, so in order to move the CSV files to a new directory, we want to follow the same process here. But instead of mkdir to make a new directory, we want mv as the command to move a file to a folder. And so that would look like this: mv file name to directory name. All right, so that's the bash command for that. So we want to automate this entire process. So there's going to be multiple steps to this. So the first step is to create this bash command mv file name directory. So that will look exactly like this code right here. My variable will be called mv file is equal to mv, and I'll have two placeholders, format, and then the first placeholder will be my CSV file, and then the second placeholder will be my dataset directory. All right, so we have dataset directory here, which is essentially datasets. So that's our folder where we're going to move files to. We don't necessarily have this yet, the CSV variable, but we do have a list of all of the CSV files that we want to move into the directory. So we need to actually go through that list and move each file individually. And in order to do that, we'll write a for loop. For loop will look like this: for CSV in CSV files, so the list of all CSV files, what I want to do is basically run this move command for each file in the CSV files list. And then I'll use the os.system command to then execute this bash command, mv file. So one thing to add is just a print statement just to see what we're doing, to see if this command actually looks pretty good. And it makes sense. You have the move command, you have the CSV file here, and then you have the dataset directory, right? So it's going to move the CSV file to the dataset directory. The problem here is that this CSV file contains a space. So what we need to do is add quotes around this file name so Python knows that it's actually one file and not two files or two words. So there's a little bit of refactoring that I'll go through here. Instead of a single quote, I'm going to use a double quote around the outside. And then right on this placeholder value, I'm going to add single quotes. So now if I do that, this looks much better. So this will be read as a single file. And so I ran this command, and I also did this OS system to actually execute on the bash command. So now if we go to the folder, we see that we have a datasets folder here, and that the CSV files have all been moved to that. Okay, so now we're ready to turn the CSV files into pandas data frames. So in the previous video, what we did was we used the pd read CSV method and just manually typed out the name of the CSV. So we want to actually automate this process right here and allow this whole process to also handle multiple CSVs. So in order to do that, the first step will actually be to replace the manual typing of the CSV's name. So instead of that, what we need to actually type in is the path to the directory. So I'm just going to call this variable data path, and then the file name itself. So in essence, what you're doing is you're giving read CSV both the path to the file and the name to the file, so it can then read it as a data frame. And next, because we have multiple CSV files, we need to save multiple data frames. So what I'm going to do is essentially create a dictionary where we're holding all of the data frames. So just to start, I'm going to type in df and then file, and I'll show you what I'm going to do with that next. So what I want to do first is actually define this data path. So this data path is the path to the file, which we know is the current working directory plus the name of our directory called datasets. So data path is actually equal to os.getCwd, get current working directory, plus then the / to denote that the next step in the path is going to be a folder. That's dataset directory, which is up here. We've already defined that right here, datasets directory, plus a / to then add the file name to the end of it. So this is our data path. Our file is actually just going to be called the name of the file. So again, we actually don't have the name of the file. We have a list of all of the file names. So there are 3 files, and we need to now write a for loop that will progress through each element in that list and grab that file name and then read that file, that CSV, as a pandas data frame. So that's going to look like this. For file in CSV files, which is our list of CSV files, basically read the file as a pandas data frame and save it into a new variable called df with a key that's the name of the file. All right. What I'm going to also add in is some error handling as well, because sometimes I get Unicode errors, and just through experience and getting all of these errors, I know how to actually handle a common error that occurs. So we're going to try this. If it works, great. Then we'll add an except, and the error is actually called Unicode decode error. So then I'll just copy this and I'll force a Unicode encoding, and that encoding is called encoding equals ISO 8859-1. So if I get a Unicode error, just encode the CSV with this encoding instead, and that should fix the problem. Or in my experience, it's always fixed the problem. So if this is successful, I just want to print the file name just so I know that it worked. All right. So the last thing is also to define this df variable here. And I said before, I want to create a dictionary to store all the data frames. So that's just going to be initialized using curly brackets. So if I run this code, I printed the file names, which we know there's 3 file names, and so they've all been printed out here. And if I actually want to see one of my data frames, just type in df, and then I'll take the first one here, and maybe I'll just output the first 5 rows. And that's what I have. So all of the CSV files have been turned into pandas data frames. All right, so now since all of our CSV files are now pandas data frames, what we want to do is clean the table names and the column names. We want to do that programmatically, and we want to be able to handle multiple CSV files or multiple pandas data frames. So what we're going to essentially be doing is reusing all of this code here, but putting it in a for loop so that we can handle multiple CSV files. So that's going to essentially look like this. All right, so I'm just going to clean up some of these comments here. So let's just start our for loop for k in CSV files. And again, our CSV files variable here contains a list of all 3 of our CSV files and their names. All right, so instead of having this, get rid of it. And I'm going to have a variable called data frame that then reads the current data frame. So df and then k, which is right here, it's basically calling in one of the data frames from the dictionary of data frames in df. All right, so the first step is actually to clean the table names. So we're going to clean the table name of the first data frame. So instead of file here, what we want to clean up is the string k, which is essentially the name of the data frame, which is also essentially the name of the CSV file. So again, if you don't remember, the name of the data frame k would be this one, and then when it progresses to the second K or the second file or the second data frame, it will be this file, and then the third will be this file. So what we were actually trying to do is clean up this, replacing the capital letters with lowercase letters, replacing any spaces with underscores, and then removing any symbols. So this is the code that does it. All right, so if that's good, I just want to print what the cleaned up table name looks like, and then we can go on to cleaning up the data frame columns. So I'm just going to copy and paste this code up here because it's going to be one for loop, and I'll just delete this cell. And it's essentially the same thing. Instead of df, I have this thing right here. I have this variable called data frame. So the data frame variable, and then the column names, and then x stays here because this is a list comprehension. So x is our placeholder variable, but instead of df columns, again, we want to use data frame dot column. So this df turns into data frames. And then we'll print df columns. All right, let's just give this a go and see what happens. I still have a df somewhere. Oh, df data frame columns. All right, so now we have printed the clean table name, which is this, and we have printed out the columns for this data frame, and we've done it for all of the CSV files. So one thing to note, we still have this .csv extension. We actually want to remove that because when we create the database table, we want the table name to be customer contracts, not customer contracts.csv, right? So maybe right in between here, we want to do that. We want to strip the .csv extension from this clean table name. So that's actually pretty easy. So let's say remove .csv extension from clean table name. So we'll save that into a variable called table name. So I'll have the table name here, where what I'm going to do is just do a format clean table name split. So I'm going to utilize the split method, split on the period here, on this period, and then save the left hand of that split, which is actually going to be indexed as 0, right? So I'm basically saying perform this operation here, and whatever this output is, save it into a string, okay? So just to be a little bit complete, let's just print this out too, so we know where we are. And I'm just going to get rid of these print statements here now because we actually know what the output is. Let's run this again. And now we have the 3 table names, or the 3 CSV files without the extensions, which will become the names of the database tables. The next step looks like we are creating the SQL statement to create the tables. So we're going to be creating 3 tables because we have 3 CSV files. What I can do is actually just remove this, remove that. We want this replacement dictionary here because it's basically mapping pandas data types to SQL data types. And we basically still want this code because this is our table schema. Okay, so let's just refactor these 2 things here. What I'll do is I will just copy and paste the replacement dictionary here with a comment that says replacement dictionary that maps pandas dtypes to SQL dtypes. All right, just to clean up the spacing, remove that. I can delete this code block here. We still want this. I can probably delete this part just to add a comment. This is the table schema. And then I'll delete this. So now to refactor this line of code here, all we need to do is replace df with data frames or data frame, and then replacements is our replacement dictionary. And so now what I can actually do just to see if I did it correctly is print out column string. All right, so I will get rid of this print statement up here and I'll run this for loop again. And then it's actually outputting the table schema here. All right, so this is, all right, so this to me looks pretty good. So I'm going to remove this print statement here. So the final thing to do is connect to the database and then create the database table and then insert the values from the CSV file to the database table. So the first thing I'm going to do is refactor this connection string here and just parse out all of these variables and values. So what that's going to look like is host is equal to, and then I'm going to just delete this and put it into a variable called host, and then essentially just have a placeholder value here. All right, and then same thing for DB name. I can also get rid of these escape keys here because it's now not a very long string. So we have something that looks like this. And so to pass the parameters into the string, all we really need to do is just type out parentheses and then host, DB name, user, and password. So what's going to happen is what the variable values are just going to be injected into these percentage s's. And this connection string here will then be used to connect to the database. So this connection string variable here holds the address to our database, and then our login credentials, that's going to be passed through to this psychopg2 library and connect method. So essentially it's going to log us in and connect to our database, which is again a Postgres database on AWS. So nothing else needs to be changed here. And what I can do is pass this up to the for loop. And so now we have successfully connected to our database. The next thing we want to do is refactor these SQL statements. So instead of manually typing in each table name, we want to refactor this code so that we can do this in a programmatic way so that it can handle multiple CSV files automatically. So I'll get rid of this, and again, I'll use a placeholder parameter here and then add the name of our table, which is table name. And so if you don't remember, we actually cleaned up the table name and saved it into a variable called table name. So we're just passing that table name into this drop table SQL statement here. So it just says drop table if exists, and then it passes the table name to the SQL statement here. So we'll just also then copy this up to the for loop. So next, let's refactor this create table SQL statement. This one basically says create table, and then we have the table schema here. So all of these values are actually saved as variables. So let's just do the same thing we did with the drop table statement and pass these variables through. So this will be a placeholder. Let me delete this escape key. This will also be another placeholder here. You can actually shorten this to just one line. And then the table name again is table name. And then the table schema is called colstr for column string. All right, so let's now pass this up to the for loop. Okay, and so now what we want to do, or now what we could do, is just test out this code just to see if it works, right? And so this is something I like to do because I like to do things in steps and then test it out to make sure that it's right. Because if we just kind of complete this whole thing and we get an error, it's much harder to just debug everything. So what we need to do now is just commit this code, and we'll just use the commit method here for the connection. So maybe what we'll do, we'll just create a print statement here after each table is created. This is just for testing purposes, but if I run this for loop, it says that I opened the database successfully, and then created the customer contracts table successfully, and then the engagement and demo tables successfully as well. So it looks like our drop and create table SQL statements are good. So now this next section is essentially saving the pandas data frame into a CSV, and then opening that CSV, loading it into memory, and then creating the SQL statement that will copy the CSV file to the table that we just created in the Postgres database on AWS. So basically this code can be copied without much refactoring. So I'm going to be copying this part right here. So insert values to table, and we'll start by saving the data frame to a CSV file. The only thing we want to do is replace this, which is the name of our CSV, or the name we're going to give our CSV, with K, and K again is the name of our CSV file. And instead of df columns, it's actually data frame columns. Instead of df, it's also data frames. Oops. So it's data frames dot to CSV. We're going to name it the CSV name that we're currently on in the for loop. And then the header will be the data frame columns, index is false, the encoding is UTF-8. Then we want to open up the CSV file that we just saved in this line here. And then instead of opening up and manually typing out customer contracts, what we can do is just say K, then we'll create the SQL statement that uploads it into the database. So I'll just take this code block, paste it into my for loop. So this is the SQL statement here. So the only thing that needs to be changed is this part right here, because we don't want to manually be typing out the table names. So I'm going to have a placeholder variable here. And then I'll place the name of the table right here. And the name of the table is the table name. And then the file that I'm going to be uploading to the Postgres database is my file, which is the file that we just opened, the CSV file that we just opened. So this is utilizing copy expert, the copy expert method. And once that's executed, the file has basically been copied to the database. So now just some finishing steps, this grant select, and then closing off the connection. So basically this grant select on table, customer contracts to public, will basically open up permissions for any user that accesses the database to access the table. So instead of manually typing out customer contracts for the table, we'll have, again, a placeholder variable. And then in that placeholder variable, we'll pass through that table name there. So we'll commit all of the code that we've basically just written here. All of that SQL code will be committed in this step. And then we'll close the connection to the database. And once that's done, we'll just print out table, and then we'll say table whatever imported to database completed, so that whatever is going to be the table name. And so that completes the for loop. And at the end, let's just have a little message. So for loop end message that basically just prints out all tables have been successfully imported into the database. All right, let's actually, all right, so now let's see if it'll work. Okay, so I have a syntax error here, which I know where it is. It's just an extra comma. And let's try one more time. All right, that was fast. Okay, so now let's just read all of the print statement. So we were able to open up the database successfully. Our first file, customer contracts, was essentially loaded to the database successfully, and that's customer engagements, and then working on customer demo file. That's completed and imported to the database successfully, and then because everything is done, all tables have been successfully imported to the database. All right, so basically one giant for loop that essentially takes a list of CSV files, goes through each one of them, and cleans up the table name, then cleans up the column names, then opens a database connection, and then drops a table if it exists, creates that table with the right table schema, and then copies the CSV file to the actual database. And then it'll do that for every single CSV file that we have in our list. So basically, the end result is a notebook that allows you to automatically upload multiple CSV files into a Postgres database without having you actually manually edit any of the code. So in the next video, what I'm going to do is I will break these code blocks and put it into functions of their own. So a function to basically read the CSV files, isolate just the CSV files and move them into a directory to process, and then a function to essentially clean up the table names, and a function to clean up the column header names, and then a function to connect to the database and upload the data to the database tables itself. So basically what you'll have in the end are functions that do all of this work that we have written up here, but they're isolated from each other and they can actually be moved out of this notebook so that the notebook is much cleaner, and it allows you to reuse these functions for other purposes other than just importing data to a Postgres database. So if you're interested in that, stay tuned for the next video and I'll show you how to do that.